May I stop sealing? Hello, sir, where is everybody? Testing, testing, 1, 2.
Lucy?
Yes, sir.
How you doing?
My mom told me I can transfer it tomorrow.
You still at work or you at home?
Yes, sir. I'm always at work when I join classes. I try to go home, I'm not gonna reach home in time.
Oh, okay. All right, I'm just waiting and see if anybody else going to join because or what I can do, I'm gonna give you a question so you can go and work for me. By the way, before I do that, were you able to go through what it is that we did last week?
No, sir. I'm not getting a chance to go through nothing this week. Not even editor stuff when I get to go on.
All right. Yeah, all right. So you need to do that for revision first. Give me a minute, just don't come.
Okay.
me see.
Yes, sir.
How comfortable are you with the multivariable differentiating multivariable functions?
That is the first order derivatives.
The first order and second order partial derivatives, yeah.
Yes, sir. I understand that.
You're comfortable?
Yes, sir.
All right.
And the COPD.
And of course, all the partial derivatives.
Yes.
All right. What I'm going to do, very good. I'm happy that you are comfortable with that. It makes my life a little easier tonight. Since it's just you alone, I am choosing to do a little bit of not even revision per se, but all right.
Sir, the class for last week is on YouTube, yes, sir?
Yeah, man. Yeah, man, I uploaded it a couple of days ago.
And what they're going to teach next Friday?
It's so like you're not going to be here.
Oh, no, man, because I missed last week. Sorry, by the way, last week we did have a migraine where not even my items could I keep open.
Yeah, I know.
Because I was trying to do something wrong. And it almost licked me down.
Wait.
So I was trying to go on this no sugar diet and I had no energy. I couldn't even stand up straight. And it gave me a migraine.
Yeah, man, you have to be careful. It put your body in shock. So what you need to do next time is to get natural sugar. So you eat banana and fruits.
Yeah, I was trying to go one day without any sugar at all. So all I had was some soup.
You put your body in shock, man. It could knock you out.
Yeah, so the Friday evening we didn't couldn't come across at all. All I wanted to do was go home.
Understood. All right. All right, I'm going to give you a question, you see? I'm going to ask you to work it. And I want to see how far you can work down. I want you to be able to solve the question for me. All the way down. So get a pencil and or pen, whichever it is that you're using to write. Now, let me give you the function. Let me know when you're ready.
I'm ready.
All right. So you're replacing nice on a Friday evening blues.
Sir, I don't know what I'm doing with the bars claim say a draw crowd, but I'm book the music.
Okay.
Yeah, we can't do no about it.
No.
If I open the door, it will be even louder.
All right. All right, write for me, please.
Okay.
F of xy is equal to x cubed plus y cubed minus 3x minus 3y plus 1. You're going to find and classify all critical points. You're going to find and classify all critical points. So you're supposed to have f of xy is equal to x cubed plus y cubed minus 3x minus 3y plus 1.
F of x squared plus y squared minus 3x minus 3y.
No, man. X cubed, not square. X cubed.
Oh, x cubed.
x cubed plus y cubed minus 3x minus 3y plus 1.
Okay, x cubed plus y cubed minus 3x minus 3y plus 1.
There you go.
Find and classify all the people. I forgot because I don't know how to do the critical points one.
Don't worry about it yet. Let us do it in stages. Do the 6 differentiation for me. First order, second order, and cross order.
Yes.
And then we can take it from there.
Okay.
You can mute in the meantime.
Okay. I'm supposed to do the COPD too?
Yeah.
Okay. I get 0.
You got 0?
Yeah, for the
first order?
Yes.
Okay, no problem. I think that's what I got to. All right, tell me what to go for F subscript X.
F subscript X, that's the first order partial derivative?
With respect to X.
0. So what do you mean by subscript X? Is that the COPD?
No, man, the first order, the FOPD.
Okay. 3x squared minus 3 plus 0.
What is XX?
6x.
What is FY?
3y squared minus 3 plus 0.
What is XYY?
6y.
All right, and then no, X, Y, and YX are both equal to 0.
Right.
All right, so you have that part. You have the calculations part. I'm trying to. Oh Lord, what did I do? Oh Lord, I did something. Okay. All right.
You should know what I mean. This is
I'm trying to log into my sharing device now. That's x cube. X cube plus y cube. Minus 3x. Minus 3y. Plus 1. Mhm. I'm trying to log on to the sharing device, but it's taking a while. So give me a minute here. All right. In the meantime, what I want you to do for me, I want you to put your fx and fy to be equal to 0 and solve those simultaneously for me. That's going to be the next step.
My f of x, first add a partial derivative.
Yeah. Of x and y, set them equal to 0 and solve simultaneously, please.
Sir, I don't know how to do that.
No problem. I'm just waiting on this very slow system to go through. Jesus. Look at that and tell me if you agree with what I have there. As I'm typing pretty fast. Agree with those?
Yes, sir.
All right, no. So all right, so if you look at it, both equations there, see if you can follow me from here now. So both equations are quadratic. How do I know? Because of the squared term, the squared quantity there. So I have 3x squared minus 3y, and I have 3y squared minus 3. Sorry, not supposed to be 3y, it's supposed to be 3, don't?
3, yeah.
And then I have 3y squared minus 3. All right, so both equations are quadratic. So I now need to solve, but I recognize that if I do something, I can if I factor out the 3, I see something that is happening. Remember, for this topic, we're not going to be canceling. We're going to be employing the rules of factorization. When we cancel, we're going to be losing, we're going to be losing values. We're going to be losing values. So what it is that we're going to do, we're going to factorize. So look at what I'm going to do. I'm going to factorize my 3, sorry. 3 is common. I'm going to make x squared minus 1. All right, so look at what is happening here. So for the first equation, I'm factoring out the 3 because 3 is common. Do you agree that 3 is common?
Yes.
Good. And then what I'm going to be left with is x squared minus 1. So x squared minus 1 is known as the difference of squares. X squared minus 1 equals 0 is the difference of squares. So I can factor.
So what do you mean by the difference of squares?
Look here. You see, when I factorize it, I get x plus 1 times x minus 1. Yeah, that's what it's called, the difference of squares. The difference because one of them is positive and the other one is negative. You notice two of them have the same term, the x and the 1 and the x and the 1.
Yeah.
The only difference with that is that one of them have a positive value and the other one has a negative value. So we say it's a difference of squares. Yeah, the difference of squares. As opposed to being a perfect square, if there's a perfect square, what do you think it would be? Suppose it was a perfect square, what do you expect it to be?
So what do you mean by perfect square? Because there's a negative sign there.
Right. So the perfect square would be either x plus 1 times x plus 1. It means that two of them are the same thing. Or you could have x minus 1 times x minus 1. So those are perfect squares. But the difference of squares though is going to be everything is the same except that one sign is positive and the other sign is negative.
Oh, so positive x squared minus 1. That's what you mean?
Right. So x squared minus 1 is known as the difference of squares. That's what I'm saying to you. So I'm saying to you, because that is the difference of squares. When I factorize the difference of squares, x squared minus 1 in particular, I'm going to get x minus 1 times x plus 1.
Yes.
So now, either
why them about the music, y'all? That's nice.
So when we do that now, we're going to get either the x minus 1 equals 0, which implies that x is equal to 1, or we're going to have the x plus 1 equals 0, which implies that x is equal to minus 1. So we have two values of x from equation 1. And we now need to calculate the corresponding values of y. So in order for me to do that, I'm going to substitute my X values into my Y values, into my second equation. I'm substituting. So I'm going to put X equal 1 into my second equation. So anywhere in that equation I see X, I'm going to put 1. And you recognize I don't have any X in there. You see that?
Yes, sir.
Good. So good example. So I can't, let me just make a notation. So since there are no X values, we need to solve equation 2 as a standalone. And what do I mean? I'm going to do the same thing like I did right here. So I'm going to just copy that. I'm going to do the same thing like I did right there. I'm going to factorize. I'm going to factorize 3y squared minus 1 minus 3 equals 0.
So if there were X values, then you would need to solve it again?
You just go ahead and substitute.
Oh. Hello?
All right. So are you sure you don't have another room you can go lock up, you know?
One moment. Who is this? Oh, hi, Miss Gardner. A letter? Unless it's your rent receipts. I haven't drafted any letter for you, so it must be a rent receipt. Yes. That must be it, because I gave it to Sandy for some time now. Okay. Welcome. Sorry, sir.
Make me co-host, please. I think it went over to you.
There, your host now.
All right, thanks. So look at the screen and tell me if you agree with it. So since there are no X values, I need to solve equation one, the second equation as a standalone. And as a standalone, I should put this here and tell you something here.
Do the same thing.
The same thing like we did before, right?
-1 or y plus 1 equals 0.
Right. But look, let me just go back up to here. So remember I factored out the 3?
Yes.
Right. So it's one of 3 things. Either 3 equals 0, but we know 3 cannot be equal to 0. So we just throw that one outside the door. Or x plus 1 equals 0, so I use that one, or x minus 1 equals 0, so I use these 2. I can't use 3 equals 0 because 3 equals 0 does not make any sense. Because you know that 3 can't be equal to 0.
Right, sir.
Hmm?
I said right.
Good. So that's why I throw it out. Now the same thing I'm going to do for this one. I am throwing out this 3 equals 0 again because it just don't make no sense. I'm just going to have now y minus 1 equals 0 or y plus 1 equals 0.
But at the same thing. It's the same thing, but you still need to work it out.
Yeah, it's the same thing? No, because remember, one is x and one is y.
Oh, right.
Yeah, so one is x, one is y. So it's really and truly not the same. So look at what is going to happen now. So look at the critical points. So remember, I have 2 x values. I have 2 x values.
Yes, sir.
I have x value where x is equals to 1 and x equal negative 1. So this x equal 1 could be x equal 1 when y equals 1. It could also be when x equal 1, y is equal to negative 1.
Yes.
Look to see if you have any other combinations from that.
X equal 1, equal 1. When x equal negative 1, y equal negative 1.
When x equal negative 1, you can have y equals 1. And also, when x equals negative 1, y equals negative 1.
Oh.
So I have several critical points. I have several critical points. I have one where x is equals to 1. Remember, I have 2 x values, you know.
Yes, sir.
I have 2 x values and 2 y values. So I can get x equal 1. So x equal 1 can go with both of these. So when x equal 1, y equal 1. When x equal 1, y equal minus 1. But I also have when x equal minus 1. So minus 1 will have to be paired with these two again. So x equal minus 1 when y equal 1, x equal minus 1 when y is equal to negative 1. So I'm making the combination of all of them.
Oh.
Because we don't know which is which. So I'm going to have 4 sets of values. 4 sets of critical points.
Makes sense.
Yeah, man. So we now need to investigate what is happening with all of these. We now need to investigate. Let me see if I can have that stuff there so I can just copy it instead of going and retyping this stuff. So I found the critical point. Let me now look at the classification. Oh Lord, I think I lose where was I? Oh man. Oh, this is where it was. So I'm at the point now where I'm doing the classification. Because remember I did say to find and classify. Right. So I have found my critical points. Now I'm classifying them. So find and classify. Good. So I'm now classifying. Let me just do. All right. Now, so I have 4 critical points that I need to look at. 4 critical points. Now remember the formula says f of xx times f of yy minus f of xy all square. So I now need to look at f of xx. F of xx is 6x and f of yy is 6y. So let me see if I can copy that. All right. So I'm recalling that f of xx is 6x and f of yy is 6y. So now, when I'm doing x equal 1, y equal 1, I'm looking at x equal 1, y equal 1. I'm looking at x equal 1, y equal 1. That's the point I'm looking at. So my f of xx is going to be 6 times 1, which is 6. And then, because there is no, remember, you know, this x value here, what is x value here? X value will be 1, don't?
Yes, sir.
So it's going to be 6 times 1, which is 6. And the y value is also 1. So 6 times 1 is also 6.
Yes, sir.
And or f of xy is equals to what again? 0, don't?
Right.
So I need to copy that so I can f of xy, copy. So sure. So right. So f of xy is equals to 0. So that is equal to, so 6 times 6 is 36. So I'm going to get f of, when 1, 1, I'm going to get 36. I know that 30.
Sir. Oh, you get that part there. 6 times 6, because 6x is 1. I mean,
No, man, x is 1.
Yes.
So 6 times 1 is the 6.
For the x value.
Right. And for y is 6y, but y is 1. So 6 times 1 is 6. So we multiply. Remember, see the formula, you know, f of xx times f of yy. So it's this 6 times this 6. It gives me 36. And 36 minus 0 is 36.
Minus f of xy. Okay. Squared. Oh. So you must automatically square.
The cross or the partial derivative, yes.
Okay.
So the COPD is going to be squared in the formula. Now, when D is positive, we're going to look at the value of f of xx. And if f of xf is also positive, we're going to have a relative minimum. Now, f of xx is positive. So
it is a relative minimum.
It's going to be a relative minimum. So I can say that since D is positive, and the value of f of x is also positive, comma, then we have a relative minimum. Look at that and tell me if you can agree with it.
All right, sir, I'll bring it up back from the top one. I'm gonna write it off.
From where?
From the cross order derivative part. Yeah.
Mute me in the meantime, please.
Oh. So how you know, say it's quadratic?
Because of the square term.
Alright, so if it was linear, how it look?
No square term, the highest
Oh, it would
order
not be
one.
square. Okay.
Right.
All right, so scroll along a little bit.
Miss everything, you know.
Yes, sir. May I write it off? I'm still finished. May I try and understand it while me I write it off. That's why. Okay, you can scroll down a little bit. You got no too far, sir. Yeah. Sir, why you say we have to use all four again? X equal one, y equal one, x equal negative one and one, y equal one, and x equal negative one and y equal negative one.
All right. So when you work out equation one, you got the values x equal one and x equal minus one.
Right.
When you work out the second equation, you got y equals one, y equal minus one. So you have to make a combination of all four now. Because remember, we're solving simultaneously. So we have to make a combination of all four. So the first x value, x equal one, is going to be paired with the two y values. The second x value is going to be paired with the same two y values.
You have to make a combination of all values. Okay, we
You have
just
to
need
come.
to check that.
Yeah.
Okay, so scroll down a little bit more. All right. All right, finish. I forgot practice this because the one I see you said in the group for last week. I know, so it looks, sir. I mean, it look the same up to the classification. No.
What you don't understand?
The one we sent before, it child pick back. All right, so you have for the FOPD of 22xy equal 22y minus y squared. So the first one.
22. Where you get 22 from?
No, the one we sent. You see, I sent the group last week, sir.
Oh no, that's a different question, and that's a totally different question. So that question has to be looked on by itself.
Oh, me I say
Because,
it look the same, it look different.
Because that one was a fraction.
Yes, sir.
That is substitute into the function. So it came out to some fractional. So it's a different question that.
Yeah.
And that was a past paper question, incidentally. It's a much harder question than this one that I'm giving you now.
Obviously. But yes, what next, sir? We're gonna go through it.
All right, so we're not finished yet, you know, because that's just classification of 1 point, D11. Remember, we have 1, -1 to do now.
1, -1.
Remember, we're classifying all the stationary points.
Oh. Okay, so that of when x equal 1 and y equal 1. So now we have when x equal -1 and y equal 1.
This is when x equal 1 and y equal -1. Ready?
Yes, sir.
So we're looking at it now when x is equal to 1, but y is equal to -1. So when x equals 1, 6 times 1 is still 6. But y is equal to -1, so 6 times -1 is -6. So this is going to be changed to 6 times a -6.
Yeah. 6 times negative, that be -36.
But remember now, the value of this don't change, so it's still going to be a -0. So D now comes out to be negative. D comes out to be negative. So from D is negative, we have a saddle point.
What kind of point?
Saddle point. From D negative, we don't have to check no f of x. From D negative, we have a saddle point. Follow me?
Yes, sir.
So if D is positive, it could be a relative maximum or a relative minimum.
So remember that on the exam too, the saddle point.
Talk truth. Yes, ma'am. So this classification finished because this one we have to do no second test. Then now we're going to go to -1, +1. Remember, we have to classify all the points here.
Yeah.
-1, 1. All right. So now we're looking at the point x = -1, y = 1. Oh, come on, Mr. Shine. -1, 1. All right. Now we have our functions. The value of x is -1. So this is going to be 6 times -1 is -6. So that changed to -6. But the value of y now is +1. So 6 times +1 is +6. So that works out to be -6. -36, I'm sorry. -6 times +6 is -36, which is less than 0.
Yeah.
So again, since d is negative, we have another saddle point. So we're going 2 saddle points and a minimum.
What is the negative?
F of xx.
Oh.
So f of xx is nobody said we don't have to do that, you know. We don't have to look at f of xx, you know, because d comes out to be negative. So once d is negative, we don't business with f of xx.
That may I say.
Right. But only business with f of xx when d is positive. Like up here, so yeah, man. So once d is negative, I just straight saddle point, you know, business but nothing more. So we have one more point to check. You finish writing?
Yeah, do the third one.
Right off the third one, yeah. I never understood the last one because I want to give it to try and own for me, you know.
Okay.
You ready? Well, what's the next half
Yeah, going to ask what time. Oh, sir, the same answer. Negative 36 less than 0. So it's only so
Same.
satisfying.
Same answer, but different points, different coordinates. One minute.
Last one.
Ready for the last one?
Yes, sir. Negative 1 or negative 1.
So the last one is going to be when it is -1 and -1.
Yeah.
All right. All right. Now, x equal -1, y equal -1. 6 times -1 is -6. And y is equal to -1, so I'm going to have -6 again. So -6 times -6 is +36. 36 is greater than 0, so that means d is positive. But f of x is negative.
So it's +36 greater than 0.
Mhm. So d is positive, which is +36. +36 is greater than 0. So d is positive. But the value of f of x is negative. Is negative. So we have a relative maximum. If it is positive, if both of them are positive, we have a relative minimum. If d is positive, but f of x is negative, we're going to have a relative maximum. Hold on a minute, please.
Okay. Sir?
Yes, Missy.
Sir, is it possible we can get an early night?
Yeah, man.
Same one
No,
closer because of the
no,
lights.
no problem. But this question finished now. So let me give you one more and just work through it quickly and then I'm gonna close out.
Okay.
All right, cool. Let me start typing it.
That's the one we want to do.
Yes, Missy, start that one for me, please.
Okay.
or you stay?
Can start the critical points part now.
Very
Yeah.
nice.
The FOPD for
Very
x and
nice.
y equal to 0.
Sorry.
So the first one is linear and the second one is quadratic.
Both of them look quadratic to me. Where you get for fx?
6x minus 6xy minus 6x.
You remember say it's 2x cubed, you know, so you're supposed to get 6x squared.
Where is cube? Oh, yeah, square. Thanks.
Mm-hmm.
So for the first one, let's it right, the part where we let f of x equal 0, meaning get you get 1 minus y equal 1. Around?
All right, hold on. Tell me what you got for fx.
Fx, I got 6x squared minus 6xy minus 6x.
Go with fy.
Yes. Oh, with fy, 3x squared plus 12y plus 3.
No, it's supposed to be minus 3x squared.
X square minus.
It's supposed to be negative 3x squared.
Where are you talking?
Now ask you if you what you got for fy.
Oh, negative 3x squared.
Right, that's correct now.
So for the first quadratic equation, it wrong. Y equal 1.
No, I'm gonna reach this yet. I just want to double check. Just want please double check to make sure I say you're right. We get the fxx.
12x minus 6y minus 6.
Say it again, 12x. Oh?
X 12x minus 6y minus 6.
What do you get for yy?
Negative 12y.
No, I mean I get that. Check yy again.
No, I'm not to do with the x. 12.
All right.
Y for drop off. Wow, sleep, man. That's one.
All right, so you make the correction now?
Yes, sir.
All right, so now that you make the correction, try the
We got 6x for the COPD.
no, keep leaving off the negative signs. I get minus 6x.
It's negative 6x, sorry.
All right. Alrighty then, alrighty then. All right, no. All right, so you are ahead of me in doing that. 6x squared minus 6xy minus 6x, and y is going to be negative 3. Please don't forget the negative signs. You have to be very careful here.
Yes, sir.
Negative 3x squared plus 12y plus 3. Double check and see if my first order is correct, please.
Square minus 6x minus 6x. Yes, sir.
All right, thanks. Check my second order for me now.
Yes, sir.
All right, and the cross order is correct. Okay, now we're going to be solving simultaneously. All right, so
Chanel, we have to leave now. We have to leave now. Because there's music. Yeah.
Sir, I have to go now.
okay. All right, finish it off for me then, and send it off in the group.
Okay, will do. Bye.
Reggie, just sneak up on me, stand out to us. Come on and say a word or two.
Yes, sir. I'm coming. I'll come in later. I think there's something in the chat.
Yeah, but I mean, I was just about to log out because I didn't expect anybody to come and then I saw you. How long have you been in class now? Were you able to check out that question, get that question?
Yeah, I saw it, sir.
All right, continue working on it for me, please. I was just about to do the other part. So that's the question. Look at it, start working on that for me, please, and then I'll see if I can just finish it off so I can be able to send out the recording with the full solution of it.
Okay.
How far you recharge?
Finishing the COP. Just writing off the COPD, sir. Well,
Okay.
I'm doing it for myself. I was looking at this school.
All right, no problem. Let me know where you are.
Hold on, sir. I'm getting something different for the first order, second order, and class order, partial derivatives.
You saying something, Raj?
Yes, sir. I said I'm getting something different for the first order, second order, and cross order partial derivatives.
What are you getting? What are you getting?
Well, right. So for the first order, so 6x squared minus 6y minus 6x. Then I'll plus 6y squared plus 3y.
No man, try the first order. Try the first order with respect to x again.
The second winning number is 23. The third winning number is 14. Okay.
It's you're right. You're differentiating the x, the values with x, right? And leaving the ones at y.
Yes, sir.
Then why is 6y squared and 3y not in it?
They say why what?
Why is 6y squared and 3y not in it? It's left off.
For which one? For which one? First order partial derivative or second order?
Yeah, first order, sir.
All right, so first order. So let us go through the first order. So see the function up here. So this is a function, 2x cubed, and I'm finding it with respect to x.
Right.
So that means I have to differentiate here. The differential of 2x cubed is going to be 6x squared. Agreed?
Right. Yes, sir.
Teacher, 6x squared. I'm differentiating here with respect to x. The y is a constant, so I'm going to put it back. See it right here, so?
Right.
And then I'm differentiating negative 3x squared to give me negative 6x down.
Yes, sir.
I put a negative 6x in front of this to get the negative 6xy. Differentiating this with respect to x is going to be negative 6x down.
Wait, hold on, sir. You say you put what in front of what?
This negative, when I differentiate negative 3x squared, I'm going to get negative 6x. So that negative 6x is going to go back with this y. See here, negative 6xy.
Right.
When I differentiate negative 3x squared, I'm going to get negative 6x. See here?
Yeah, yes, sir. Yes, sir.
But when I differentiate these two terms, because I don't have no x in there, it'll go to 0.
Oh, they're just 0. Okay, so you don't put them back. Okay. That's what I was doing. I was putting them back instead of making them 0.
Mhm.
Okay, so let me do it again.
The third winning number is 4, and the fourth and final winning number is also 4. Once again, the winning 4 numbers are 9, 8, 4.
Hey, John. Hello? Hello? Or you stay now?
I got it, sir. Kind of stuck on the simultaneous equations part.
No problem. So let me work through the simultaneous with you now. So hold on. So we need to solve simultaneously. Now, this one must be done by substitution. This simultaneous must be done by substitution. Now,
How you tell, sir?
because I have two quadratic equations. So I can't do elimination. Elimination is only done for linear functions.
Right.
So I have to solve it by substitution. Once I have a
Okay.
quadratic inside, either one or two equations with quadratic, I have to use substitution method.
Okay, sir.
Yeah, man. So I'm solving using substitution. Now, I can't use the second equation because the second equation has both. I could use the second equation. I could use the second equation and make y the subject of the formula. But I'm going to use the first equation. So I can use any one of them. So I'm going to make y the subject of the formula. So I'm going to have, I'm subtracting 6y from both sides. So I'm going to have 6x squared minus 6x equals 6y squared. Look at that and tell me if you agree with that.
Six x squared minus 6x equals 6xy squared.
No, man, look at it again.
Let's see, 6x squared minus 6x equals 6xy. So it just took 6xy from the equation. You say you minus 6xy from both sides. That's what you said, sir.
No, I'm adding 6xy to both sides. I'm making 6xy the subject. I want to get y the subject.
Oh, so yeah, add it. So so that the 6xy was negative, and then adding it would make that 0. And then on the outside, add 6xy, so it's to the 0, so it's 6xy on the outside. Okay.
You follow that?
Yes, sir. Follow it.
And then I'm going to divide both sides by 6x. Why am I dividing both sides by 6x? Because I want to make
You want
y
to
the
leave y
subject.
alone. Yeah.
Right. Very good. When I do that, I'm going to get x minus 1 is equal to y. Look at that and tell me if you agree.
You need for all of them because what they do on the right side, they do on the left side, and vice versa.
Mhm.
Yeah, yes, sir. I get it, sir.
Agree?
Yes, sir.
All right. So now I'm going to put this into, let me label these as 1. So anywhere in equation 2, I see y, I'm going to put
X minus 1.
x minus 1. Very good. Look at that and tell me if you agree with it. Sorry. I put it in there. I shouldn't put hold on. So this is equation 2. That's equation 2. And in equation 2, I see a y right here. So I'm going to put in x minus 1. You see that?
Yes, sir.
And then now 12 times x is going to be
12x.
12x. And 12 times -1 is going to be -12
Negative
down.
12. Yes, sir.
And then again have +3. Agreed?
Right.
And then -12 plus 3 is going to be -9. Don't.
Yes, sir.
And then I'm going to divide through by -3. Why I'm dividing through by -3 so I can get the coefficient of x squared to be positive. So I'm gonna have x squared minus 4x plus 3. Look at that and tell me if you agree with me. 3 is common to the equation. Negative 3x squared plus 12x minus 9 equals 0. So I'm dividing through by negative 3 so that I can get the coefficient of x squared to be positive. Let me know if you agree with me.
Okay, and you use 3 because it's a factor of all those
Very good.
terms.
Very
Okay.
good. Agree?
Yes, sir.
Okay, in fact, can you factorize x squared minus 4x plus 3 for me and tell me what to get?
Is x squared minus 1. Is
When you say x squared minus 1, what do you mean?
that's the first. Oh wait, no. It's x open brackets
Mm-hmm.
wrong sir.
Yeah, man, remember we multiply the coefficient of x squared by the constant. So 1 times 3 is 3. You need two numbers. When multiplied together will give you 3, but when added will give you a negative 4. What two numbers are they?
Two numbers when you multiply gives you +3,
Mhm.
but when added gives a -1.
Mhm. Talk to me now.
-3 and -1.
Very good. So it takes so long to tell me.
We actually remember how factorization works. Like.
Look to see what I have if you're agreeing with them.
-1x -3. Sir, the sign before the plus sign for the 3 changed because whatever's in the first bracket must be in the second bracket, right?
Yeah, not just that, because I'm factoring out a negative sign. So this negative sign times this 1x gives me -1x, and this negative sign times this negative sign will give me the +3.
Okay.
Yeah, so once I factor out a negative sign, this sign here has to flip, and then now your second point comes into play now. Whatever sign that is in this bracket has to be the same sign that is in this bracket in order for you to factorize it. So you see, x minus 3, I factored out to get my x minus 3, and what is going to be left is going to be x minus 1. So those are they. And then now, we're going to say either so either x minus 1 equals 0, and this implies x is equals to 1. And
One implies x is equal to 3.
good job. All right. So we have a value for x. We have values for x. So now we need to recall this one. So we need to recall that y is equals to x plus x minus 1. So what I'm going to do now is to put x equal 1 into y. Put x equal 1 into y. What is 1 minus 1?
0,
So y is going to be equals to
0.
0.
So either y is 0 or y is 2.
I will. Oh, no, the critical point here is a door. CRITICA. The critical point will be 1,
and
0.
1,
Done.
0. Oh yes, 1, 0. And
That will be 1, 0. And then I need to do the same thing. I need to put x equals 3
into y.
into y. Three minus 1 equals.
2.
So yes, you're correct. So y is going to be equals to 2. And the critical point here is going to be x equals 3, y equals 2. X equals 3, y equals 2. I'm going to ask you to hold on a minute, please.
Okay, so
Yeah, man. So you following what I mean right here?
Yes, sir, I see it.
Mhm. So so those are the so those are the critical points. I have two critical points of this question, and then now we need to classify. So let us see if we can classify and then call it a night. We need to. I'm just looking for something. I don't want to have to go and retype it. So we need to classify. Let's do this. Classify the points. Let us use a point 1, 0 first. So it's f of x, x times f of y, y minus f of x, y. So I'm using a point 1, 0. All right. Now my f of x, x. And my f of y. So my f of x, x is 12x minus 6y minus 6. So work with me now. When, so x is 1, y is 0. So this goes to 0 because y is 0. Talk truth.
Yes, sir.
12 times 1 is 12, don't.
Right.
And 12 minus 6 is 6.
Yeah.
So f of x, x is 6. So I don't have to erase this 6. So this 6 is this. F of y, y now. F of y, y don't have not to substitute in, so it's going to be 12, don't.
Yes, sir.
And then now, f of xy, x is 1. So negative 6 times 1 is negative 6. So that's going to be negative 6 squared. And then 6 times 12 is 6 times 12 is 72.
72.
Right. And then minus negative 6 squared is 36. So it's going to be minus 36. It's going to be positive 36, and that's greater than 0. So because it's greater than 0, you know that it's going to be, since this is positive, the
Minimum.
value of f of x, and the value of f of x is also positive, then we have a relative minimum. You see that?
Yes, sir.
All right, good. That's 1, 0. Then we can look at the last one, 3, 2. We're looking at 3, 2. So work with me again. So in this case now, x is 3, y is 2. So 12 times 3 is
36.
36. Minus 6 times y, 6 times 2 is
12.
12, and minus 6. So that is going to work out to be 18. So 3, 2 here. First one is going to be 18, a positive 18. All right. And then now, f of y is just going to be 12, don't?
Yes,
Because
sir.
we don't have anything to substitute. Now, for f of xy now, x is 3. So 3 times 6 equals 18. So that's negative 18. So 18 times 12 is equal to 216 minus 18 squares That's going to be equals to negative 108.
So it's negative 18 squared.
Yeah, negative 18 squared going to give you a positive value. It's going to
Right,
give you
right.
positive 324. But 18 times 12 is going to be 216. So it's going to be 260 minus 324, which is equals to negative 108.
Okay.
So I'm going to have time to write all of that. I'm just going to copy it. So so since D is negative, then we have a saddle point. We don't have to check f of xx. Since D negative, we have a saddle point. Fair enough?
Yes, sir, that's clear.
All right. I'm going to leave it here. I'm going to see if I can send off this thing to you from tonight so that you guys can have it to work with. All right?
Okay, sir.
Please to go through your Edicus software and
Yes, sir.
complete the work. All right. Thank you, Mom. All the best.
All right, thanks, sir. Good night.
Boom.